Before you even consider liking this video, ask yourself one simple question. Why would a space agency built to explore Mars, Jupiter, and distant stars suddenly spend millions studying the darkest parts of Earth's oceans? If that sounds strange, good, because the answer is far more unsettling than you think. NASA isn't just exploring the deep sea for training or technology. They're hunting for something far more fundamental. Something that could explain how life begins, where it hides, and why it might be far more common in the universe than we ever imagined. If that idea intrigues you even a little, tap like now. It tells the algorithm this is the kind of science worth sharing. For decades, we assumed life needs sunlight, warmth, and gentle conditions, but the deep ocean shatters that assumption completely. Miles below the surface, where sunlight never reaches and pressure can crush steel, entire ecosystems thrive. Not just survive, thrive. Life powered by chemistry instead of light. Life that doesn't breathe oxygen the way we do. Life that exists in conditions almost identical to those found beneath the icy crusts of Europa and Enceladus. And that realization flipped NASA's priorities upside down. Because if life can exist here, in Earth's most hostile environment, then oceans hidden beneath alien ice may not be empty at all. But here's the part most people don't realize. The deep ocean isn't just an analogy for alien worlds. It may actually preserve conditions similar to the earliest stages of life on Earth itself. Some scientists now believe life didn't start on sunlit shores, but deep underground, near hydrothermal vents, protected from radiation, impacts, and chaos on the surface. In other words, Earth's deepest oceans may not just resemble alien worlds, they may be where life itself first learned how to exist. That's why NASA studies deep-sea microbes with the same seriousness they study Mars samples. That's why astronauts train underwater to simulate isolation, pressure, and limited resources. And that's why robotic probes designed for space are being tested in trenches deeper than Mount Everest is tall. NASA isn't preparing for space by accident. They're rehearsing, because what they're finding at the bottom of the ocean may reveal the rules life follows everywhere. And once you understand those rules, the universe suddenly feels very different. The moment everything changed came when scientists discovered hydrothermal vents on the ocean floor. These towering structures spew superheated, mineral-rich water into freezing darkness, creating pockets of energy where life shouldn't exist, but does. Entire ecosystems form around these vents without a single ray of sunlight. Bacteria feed on chemicals. Larger organisms feed on bacteria. A complete food chain emerges in total darkness. That discovery didn't just rewrite biology, it rewrote astrobiology. Because Europa, one of Jupiter's moons, likely has the same exact setup: a global ocean, chemical energy, and heat from below. NASA quickly realized something terrifying and exciting at the same time. If life emerges wherever energy and chemistry meet, then life may not be rare at all. It may be inevitable. That's why NASA's Jet Propulsion Laboratory began collaborating with oceanographic institutions, adapting space-grade robotics for the deepest parts of Earth's oceans. Some of these machines failed spectacularly, crushed by pressure or lost forever in the abyss. Others returned with samples showing microbial life living inside cracks in Earth's crust itself, life completely isolated from the surface. And this raised a deeply uncomfortable question. If life can exist entirely underground, protected from extinction events, then how many times has life survived when we assumed it was wiped out? And how many alien worlds might still be alive beneath their surfaces, invisible to our telescopes? If this thought is bending your mind, hit like. It tells YouTube this isn't just entertainment, it's perspective-shifting science. But the discoveries didn't stop with microbes.
As probes descended deeper, they encountered creatures that look more alien than anything in science fiction. Transparent organisms exposing their internal organs, predators with jaws designed for crushing darkness, species older than dinosaurs, unchanged for hundreds of millions of years. These aren't just curiosities, they're proof that evolution doesn't follow one path, it adapts to whatever rules the environment imposes. Which means alien life may not resemble Earth life at all, except in one crucial way. It will obey physics, chemistry, and energy constraints, and those rules are universal. NASA doesn't need to find aliens to know this. Earth already provides the evidence. The deep ocean is not a monster-filled abyss. It's a laboratory that's been running uninterrupted for billions of years, and every discovery down there narrows the question from could life exist elsewhere to how could it not?
This is where NASA's ocean obsession connects directly to its most ambitious missions. Europa Clipper, the spacecraft now on its way to Jupiter, isn't just looking at ice, it's looking for cracks, heat signatures, and chemical plumes, the same markers scientists use to locate hydrothermal vents on Earth. When Europa ejects water vapor into space, NASA doesn't see geysers, they see opportunity. Because if microbes exist beneath Europa's ice, those plumes could carry chemical fingerprints of life directly into space. And suddenly, searching for alien life doesn't require drilling through miles of ice. It requires flying through the spray. But here's what makes this even more profound. The technology being used to search Europa was refined at the bottom of Earth's oceans. Autonomous navigation, extreme pressure resistance, instruments capable of detecting life without direct contact. The deep sea is where NASA tests the future of astrobiology, and every successful dive increases confidence that alien oceans are not sterile voids. If you've stayed with me this far, like the video, because the next part is where everything comes together. Some scientists now believe that intelligent life elsewhere in the universe may not evolve on land at all. It may remain underwater, protected, stable, and invisible to distant observation. Civilizations could exist beneath ice-covered oceans, never building radio towers, never launching satellites, never signaling their presence. To us, they would appear completely silent. This possibility reframes one of the biggest mysteries in science, the Fermi paradox. Maybe the universe isn't empty, maybe it's just submerged, and Earth's deep ocean gives us a preview of what such worlds would be like: stable, long-lived, hidden. When NASA studies the abyss, they're not just searching for organisms, they're testing a hypothesis about the universe itself. That life prefers shelter over exposure, depth over surface, chemistry over sunlight. And if that's true, then the most common type of life in the cosmos may live exactly where we're least equipped to look. Until now.
So what is NASA really looking for at the bottom of the ocean? Not monsters, not lost cities, not secret technology. They're looking for confirmation that life is resilient, adaptable, and fundamentally difficult to erase. They're looking for proof that life doesn't need paradise, just opportunity. Every microbe living near a vent, every organism thriving under crushing pressure, every ecosystem surviving without sunlight strengthens the case that the universe should be alive. And that realization has consequences. It means Earth may not be special because it has life, but because we can see it on the surface. Other worlds may hide theirs far better. And as we prepare to explore Europa, Enceladus, and Titan, the lessons learned in Earth's oceans will guide every decision. Where to look, what to measure, what counts as evidence. NASA's search isn't random, it's methodical, because once we find life beyond Earth, even microbial life, the story of humanity changes forever. Biology becomes cosmic, evolution becomes universal, and the question stops being, are we alone, and becomes, how much life has been hiding from us this whole time? If this video gave you even one new way to see the universe, hit like. It helps this kind of science reach people who never knew they were curious. And remember this, the greatest discovery in human history may not come from the stars above us, but from the oceans beneath our feet. Because sometimes, to understand the universe, you have to look down, not up.